Assalamu alaikum my dear students, hope you are well by the grace of Almighty Allah. Welcome to an IBS Home School. This is Emdadul, Assistant Teacher of Mathematics, National Ideal English Version School, Rashid. Dear students, today I am going to conduct a math class of class 8. Our today's topic is chapter 8 Q-1. It means that I will solve a creative question in our today's class from chapter 8. Okay dear students, let us see what is our creative question 1. Here creative question 1 I have written. Here is a figure given. PQRS is a parallelogram. Here PRQS be two diagonals. Here I have written two diagonals, PR and QS of a parallelogram intersect at point O. Here the parallelogram is PQRS. The diagonal PR and QS intersect at O. Now first question A. Find the area of the rhombus whose lengths of two diagonals are 8 cm and 9 cm. It means that when the length of two diagonals are given, we need to determine the area of the rhombus. Dear students, so let us see how can we solve the first question at first. Question A. Here the diagonals of a rhombus are given. Here the diagonals are 8 and 9. 8 and 9 centimeter. So we can write here given the diagonals of a rhombus are D1. I have considered the first diagonal as D1, that is 8 centimeter, and another one D2, that is 9 centimeter. We need to determine the area of the rhombus. We know the area of rhombus. When two diagonals are given, then we can write the formula for determining the area, that is half D1 D2. Half D1 D2. Half D1 D2. So we can write here therefore the area of the diagonal, the area of the rhombus, the area of the rhombus. So we can put the value of D1 and D2 here. D1 is 8 and D2 is 9. The area will be square centimeter. Area will be square centimeter. So we can calculate here. We can divide by 2, we will get here 4 9s are 36 square centimeter. This is our required area of the rhombus. Therefore the required area of the rhombus is, therefore the required area of the rhombus is 36 square centimeter. Okay dear students, so I hope you have understood the solution of question A. Now I will solve question B. So let us see what is question B at first. Prove that PO equal to OR and QO equal to OS. Here if you notice the figure here, PO equal to OR and QO equal to OS. What does it mean? It means that PO and OR are equal, that is O is the midpoint of PR. It means that the diagonals bisect each other. We need to prove the diagonals bisect each other. This is theorem 3 of chapter 8 of your book. Dear students, so let us see how can we prove this. The diagonals of the parallelogram bisect each other. How can we prove? We can show here. The students, now see here, we can write solution of B. two diagonals PR and QS of a parallelogram PQRS intersect at O. It is required to prove that PO is equal to OR and QO is equal to OS. We need to prove this. As the figure is given, we will draw the given figure here must. The students, you need to remember that if you don't draw figure, proof completely, you will get 0. You will get 0 marks if you don't draw figure. To answer question B and C, the figure may be given in the question or not, but you have to draw. If you don't draw the figure, the mark will be 0. PQRS. Here is O according to our given figure, and I have written here two diagonals PR and QS of a parallelogram PQRS intersect each other at O. It is required to prove that PO equal to OR and QA equal to OS. It means that the diagonal bisect each other. We need to prove this. So we can prove here. To prove, construction is not necessary here. So directly we can prove here without construction, as extra construction is not needed. To prove this, at first we can compare these two lines PQ and SR. PQ and SR. If we consider PQ and SR, PR is the transversal. These two sides must be parallel, as PQRS is a parallelogram. Opposite sides of parallelogram are parallel. So we can say here PQ parallel SR, PR is the transversal. So the produced alternate angles are equal here. It means these two angles are alternate angles. Okay. So at first we can write here PQ parallel SR. PQ parallel SR and PR is the transversal. This is step 1. This is step 1. PR is the transversal. So we can write therefore angle QPR is equal to angle PRS. We can write angle QPR is equal to angle PRS. What is the reason? The reason is alternate angles are equal. Alternate angles are equal. When a line intersects two parallel straight lines, then the produced alternate angles are equal. As a result, angle QPR is equal to angle PRS. Okay, now we can write here step 2. Again, PQ parallel SR and QS is the transversal. QS is the transversal. As QS is the transversal, so we can say therefore angle PQS is equal to angle QSR. PQS is equal to angle QSR. QSR. These two angles are equal. What is the reason? Same reason here, as PQ and SR are parallel, alternate angles are equal, and QS is the transversal, so alternate angles are equal. So we can write here alternate angles are equal. Okay, dear students, so we can say these two angles are equal and these two angles are equal. As these two angles are equal, now we can compare two triangles here. If we compare the triangle here, POQ and ROS, if we compare these two triangles, then here we will get step 3 in triangle POQ and triangle ROS. We will get here angle QPR. It means that angle QPO. So we can write here angle QPO is equal to angle, which one? This one. This one is ORS. Here I have written PRS. So we have to write here ORS. But how can we write? Dear students, in the first step we have shown QPR is equal to PRS. Here O and R on the same line, so we can say QPR means QPO. It means that we can write in the side note as angle QPR is equal to angle QPO. And another one, angle, this one, PRS. This angle we can write as QRS. Sorry, ORS. Both are same. For this, we can write this too. Angle, now we have seen here PQS. Here PQS means PQO. So we can write angle PQO is equal to angle here QSR means OSR. So we can give the side note here angle QPS, angle QP, sorry, not QP, PQS. PQS. Here is PQS. It means PQO. That is equal to PQO, as S and O lie on the same straight line. And another angle I have written here OSR. That means here is QSR. That means OSR. So we can write here angle QSR is equal to angle OSR. For this we can write here angle OSR. As these two angles are equal, so these two must be equal. For this I have written PQO is equal to OSR. Now if you notice here, you will see here this angle and this angle are equal, this one and this one are equal. So adjacent side of this two angle is PQ and here adjacent side is SR. So we can say these two sides are equal, as PQRS is a parallelogram, opposite sides are equal. So we can write here and Q is equal to SR. S R or RS, we can write anyone, no problem here. PQ equal to RS. PQ equal to RS. As these two sides are equal, we can write here as PQRS is a parallelogram. Opposite sides must be equal. As this is a parallelogram, opposite sides must be equal. So now if you notice here two angles and their adjacent side of a triangle is equal to two angles and their adjacent side of another triangle are equal. So these two triangles must be congruent. We can say therefore triangle POQ is congruent to triangle ROS. POQ means POQ is equal to is congruent to triangle ROS. As these two triangles are congruent, we can say corresponding or similar sides are equal. So PO equal to OR and Q equal to OS, we can say. Therefore PO equal to OR and QO equal to OS. What we need to prove? If you see here, we need to prove PO equal to OR and QO equal to OS. So the proof is done here. The proof is done here, proved. Okay, dear students, I hope you have understood how to solve question B. Now I will solve question C. What is question C? Question C is if PR equal to QS, then prove that PQRS is a rectangle. PQRS is a rectangle. Here the condition is PR equal to QS. Here PR and QS are two diagonals. It means that if the diagonals of a parallelogram are equal, then we need to prove that the parallelogram will be a rectangle. So we can write here again, see the question, if PR equal to QS, then prove that PQRS is a rectangle. It means that here PR is a diagonal, QS is a diagonal. It means that if the diagonals of a parallelogram are equal, then we need to prove that the parallelogram must be a rectangle. So we can prove C here. We can write here PR and QS, PR and QS be two diagonals of a parallelogram PR and QS be two diagonals of a parallelogram PQRS, and PR is equal to QS. PR equal to QS. It is required to prove that PQRS is a rectangle. Dear students, at first we have to draw the figure here. Draw the figure of a rectangle. this is P, Q, R, S. Here the diagonals are PR and QS. PR and QS. The diagonals are PR and QS. It is required to prove that PQRS is a rectangle. In this case, the diagonals are equal. That is given. Okay, dear students. Now see, we can prove here. Construction is not necessary here. So, step 1. How can we prove? Dear students, if you notice here, PQRS is a parallelogram. In this parallelogram, we have drawn two diagonals PR and QS. This PR diagonal form a triangle PQR and QS diagonal form a triangle SQR or SRQ. We can say anyone. PQR, another one QRS. We can compare these two triangles here. If we compare these two triangles, what will we get here? As this is a parallelogram, these two sides are opposite, it means length of these two sides are equal. And here, if you notice, diagonal PQ is equal to diagonal QS. Diagonal PR is equal to diagonal QS. So, these two sides also equal. Now, QR is the common side. QR is the common side of both triangles. So, if you apply the side theorem of congruency of two triangles, you will get these two triangles PQR and QRS are congruent. If these two triangles are congruent, then you can say these two angles PQR and QRS are equal. If these two angles are equal and as this is these two angles are consecutive angles of a parallelogram, sum of their measurement will be 180 degree or two right angles. So, each of the angle will be 90 degree. It means that here angle QR are 90 degree. As opposite angles of a parallelogram are equal, so angle S and Q are equal. This is 90 degree. So, R and P are equal, it means P also 90 degree. It means all the angles are 90 degree. Just we need to prove only one. If we can prove only one angle is right angle of a parallelogram, then the parallelogram will be a rectangle. So, just we need to prove angle Q or R or both angles are right angle. If we can prove, then we can say the parallelogram PQRS is a rectangle. So, we can write here in triangle PQR and triangle QRS. PQR and QRS. If we compare these two triangles here, we will get here PQ equal to SR. PQ equal to SR. Opposite sides of parallelogram are equal. Opposite sides of parallelogram are equal. Now, step 2. Sorry, no need to write step 2, just step 1. We need to compare here another side. PR equal to QS. PR is equal to QS, as these are two diagonals and this is given PR equal to QS. We can write here by hypothesis. It means given. By hypothesis, it means given. And QR equal to QR common side of both triangles. common side. This is the common side. QR is the common side of both triangles PQR and QRS. So we can say three sides of triangle PQR and three sides of triangle QRS are equal. It means that by the theorem side theorem of congruency of triangle, we can say triangle PQR is congruent to triangle QRS. As these two triangles are congruent, we can say here angle PQR, angle PQR is equal to angle QRS. These two angles are equal. Now if you notice here, sum of these two angles must be two right angles. So we can write here again step 2, angle PQR plus angle QRS is equal to two right angles. Two right angles means 180 degree, as these are two adjacent sides of a parallelogram. So we can say now we can replace QRS by PQR, or angle PQR plus angle PQR, that is equal to two right angles. Now we can write here 2 into angle PQR is equal to two right angles. That implies angle PQR is equal to one right angle. Dear students, what does it mean? It means that we have proved that, already we have proved that angle PQR is a right angle, and we know PQR and QRS are equal, so we can say therefore angle PQR equal to angle QRS is equal to one right angle. Dear students, you know that if an angle of a parallelogram is a right angle, then the parallelogram is said to be a rectangle. So, or therefore, we can say PQRS is a rectangle. We can write according to the definition of rectangle. Definition of rectangle: PQRS is a rectangle. Okay, dear students, so I hope you have understood the proof of CQ1. Practice this creative question at home more and more, and do this as your homework. This is your homework 17. Okay, dear students, do your homework properly, submit your homework timely, keep practicing at home, abide by your parents, stay home, stay safe. See you again. Till then, assalamu alaikum.